Hello, my name is Anna Rosinke, and together with my partner Maciej Chmara, we have been working for over 10 years on culinary spaces, food culture, and their social dimensions. Since 2021, when Maciej began a collaboration with Charles Spence from the Institute of Experimental Psychology at the University of Oxford, our focus has shifted toward exploring the role of bread in society. While bread may appear simple, it's incredibly complex, anthropologically, microbially, and in terms of its potential as a multisensory experience. In the speculative paper, the Cooking Ape Institute, Neuro-Cooking, the Society of Food Preparation, realized during the first Musaya residency, Chmara envisions a future in which food preparation is valued as highly as consumption itself. In this imagined society, cooking is not merely a means to an end, but a central aesthetic and therapeutic practice. Food culture in this context is built on three interconnected pillars: mental, planetary, and physical well-being. Instead of being prescribed medication, a visit to a doctor may result in a recommendation for a bread and dough yoga course. Our ongoing collaboration with Charles Spence challenged us to consider how technology could be meaningfully integrated into sensory experiences to support mental well-being. Cooking, and particularly working with dough, has therapeutic potential for both physical and psychological health. During the second Musaya residency, we have been working in cooperation with mbraintrain, a mobile EEG company based in Belgrade, on developing a tool to support therapy for conditions like food-related anxiety or impaired motor function. This tool is designed to be integrated into established therapeutic practices such as mindfulness-based stress reduction, MBSR, or various forms of occupational therapy. We developed a mobile system to measure brain activity, EEG, pulse, muscle contractions, EMG, and hand movement. With 30 participants, we conducted a study to build an emotional model capable of interpreting users' mental and physical states in real time. This model serves as foundation for a responsive feedback system.
My name is Danko Radulovic, and I'm an industrial designer at mbraintrain company. We use the DFA process to reimagine cooking as an emotionally aware experience. Our prototype merges EEG, smart textiles, and sensory feedback in a human-centered, sustainable way. It helped us design with an empathy and imagine more meaningful interactions with technology. The experience with the Musaya project was truly inspiring. It challenged us to develop our ideas in depth, both theoretically and practically, and pushed us to think more critically about the future impact of our designs.
After exploring different approaches, we chose a very honest design language, one that brings the technology aesthetically to the forefront rather than hiding it. To ensure comfort and optimal functionality, the wearable device can be customized using 3D scans of individual head shapes. This personalization supports prolonged therapeutic use and ensures accurate sensor placement. We are also addressing the technical challenges commonly associated with mobile EEG systems, including cable management, signal interference, and artifact reduction. Our design aims to enable clean and reliable data collection suitable for research environments. Instead of relying on complex composite textiles that are difficult to recycle, we are exploring slightly over-engineered mechanical solutions made from recyclable or biodegradable monomaterials. This offers durability while being more sustainable and easier to disassemble or repurpose. Our wearable technology analyzes hand movement and, together with emotional model, assesses whether the experience feels comfortable or stressful. When stress is detected, the device can respond with rhythmic vibrations and gentle pressure, guiding the user towards a slower, more calming motion or technique. While language is essential for communicating recipes, we found it not intimate enough to describe the deeply sensory practice of working with dough. Instead, we imagine something like a hand guiding your hand, a gentle and responsive presence. Drawing on research from Oxford and MIT, we created tactile patterns using LRA haptic motors. These haptic responses are triggered by live data from EEG, EKG, and EMG sensors, creating a wearable system that supports the development of therapeutic breath-making routines. Our ambition is not to create another gadget, but a therapeutic learning tool. It is intended for temporary use during a phase of healing or relearning. We are using new technologies not for their novelty, but as a means to counterbalance the disconnection and sensory imbalance caused by our increasingly digitized lives.